It's me, Jordan, again, back with another programming video. This one explaining the exciting topic of autonomous in FRC Robotics. So, autonomous is the brief section at the beginning of a match, the very first 15 seconds of the match that robots run completely by themselves. So, there's no drivers, just the robots run themselves for the first 15 seconds, only on the code. And this is where everything relies on the programmers of your team. So the programmers are very responsible for this, and it's very important that the programmers take time and they make sure that they have something for Auton, because Auton is pretty important. It's not as important as Teleapp, but I would say that it's still super important, and it's very impressive to have a very nice Auton. So today in this video I will show you how to make an Auton using just basic time-based code, so just using time to then make motors move for a certain amount of seconds. This is very basic and any team can do it as long as they have the same Java code and as long as they have 4 moving motors to drive, or however many motors they use to drive. As long as they have those, you can do this for autonomous. So this is very simple, but we are going to go into, and we are going to start this off by just creating a command. I have 3 different autons, so I have autofeed.java, autoinfront.java, and autowrite.java. So these are my 3 auton commands. So it doesn't matter how many you have. Auton, you can have as many as you want, the more the better, because then you can select between them when you're in a match. So then if you, like, one of your alliance members is like, hey, that Auton's going to be in our way, by chance could you move over, or can you pick a different spot? You don't have to be like, no, I only have 1 Auton. So then if you have more than one, you will probably do better when it comes to matches, because then you and your alliances can work it out. And plus you'll have more options. So maybe one match you'll see more beneficial to shoot, but then another match it might seem more beneficial to get in a ready spot, ready to do whatever action you're going to do as soon as it's teleapp. So it's good to have a whole bunch of different options. So right now I have 3. But yeah, you're going to create a command. So if you remember correctly, right click on command, create a new class, / command, create a command, name it, and then open it up. So I'm going to open up my AutoInFront. So compared to my other commands, these are my commands that actually have some bulk to them. You don't need to really import too much. The only thing you really need to import is the timer, because you're going to need a timer when you code this. So import that timer right there. And then we're going to scroll down a little bit. So in the public class AutoInFront extends instant command, we have 3 things in here. We have double my start time, double my time, and boolean my auton finish equals false. So double my start time, that right there is our number for our timer. Same with double my time. So those are both having to deal with the timer that we set up. So when we put those in, we need those for our timer, because we need to tell Java, hey, start counting, so then we can use those values for as it counts to then tell it, hey, when you're at 4 seconds, do this. When you're at 6 seconds, do this. When you're at 1 second, do this. So we need to make sure that we make a timer. So that's why these 2 lines are very important. And this one right here is going to be used to tell the command when we're done with Auton to be like, okay, shut everything down so it doesn't continue to run. So like, let's say if we make an Auton that actually takes only 5 seconds and doesn't take 15, it doesn't just keep running this Auton over and over and over again. It's just going to tell itself to stop and not do it again. So we need to make sure we have this false boolean also. So we're going to scroll down a little bit. So in public AutoInFront, we need to write requires, our require statement, robot.drivetrain. And the reason why it requires robot.drivetrain is because the drivetrain is what we use to drive. And a lot of what this command has to deal with is just driving, right? And just driving. So it'd be the smartest to put that as it requires. Then in our initialize, so protected void initialize, we need to make sure that we state the clock / timer. So my start time is equal to system.current time milliseconds. So this right here tells it to create in the system a timer that does the milliseconds. So it's going to start counting milliseconds. System.outPrintLine my start time plus my start time. So this right here is telling it to, in the real log, to print the seconds as they fly by. And then finally in the initialize, we need to put my time is equal to 0. So it's telling the code, we're starting at 0. We're not starting at like 50 or something like that. We're starting right at 0. I'll scroll down to the execute. So my time is equal to system.current time milliseconds, so this up here, parentheses, minus my start time. So it's going to minus the time that we started with. And it's going to divide it by 1,000. And the reason we divide it by 1,000 is because if you remember correctly, it's in milliseconds. So by dividing it by 1,000, we are making it just normal seconds. So that causes it to where we don't have to deal with trying to calculate milliseconds. We can just do seconds instead. So then system.out.println my time plus my time. So once again, that's telling it, hey, print out the times so then we can watch on the real log, make sure that everything's going well. So then we got a lot of if statements coming up. So if my time is greater than or equal to 0, so if my time is greater than or equal to 0, and my time is less than 2 seconds, it's going to, first of all, system out print the line stage 1, so it's saying that, hey, you're in stage 1, and this is very beneficial. So like, let's say if you're running all these stages, and something's not working properly, by printing out these lines after each, or during each stage, it will tell you which stages are working. So then let's say this stage works and the third stage works, but the second one doesn't work. By putting these in here, it will then print on the real log, so then you know which one exactly is running and which ones are not. So if my time is greater than or equal to 0, but is less than 2 seconds, so if it's greater than 0 seconds or but less than 2 seconds, it's going to run what's in this if statement. And what's in this if statement is robot.drivetrain apply motor power. So we're going to apply the motor power, and if you remember correctly, the motor power, which is right here, is just the driving basic driving code in the drivetrain. So since that's the basic code right in the drivetrain, I'm just telling it to apply negative 0.26 to the left and negative 0.25 to the right. And you might be asking why I'm having an extra percent on the left than the right. And the reason why is because the left is going a little bit too fast, or a little bit too slow for some reason. So the robot's kind of curving instead of going straight, so I added an extra percent, and that fixed it. Okay, so since that's stage 1, and after stage 1 we want to go to stage 2, we notice how our time ended at 2 seconds. So in the next stage, we're going to put if my time is greater than or equal to 2 seconds. So this one ends, and then it should go straight to this one. And my time is less than or equal to 4 seconds. What it's going to do is it's going to tell the robot to do robot.drivetrain.apply power 00. And what that does is just gets it to stop, so then it doesn't keep rolling. So by doing that, you're just telling the robot, hey, stop what you're doing. Don't do anything else. From there, we got the if statement. So if my time is greater than or equal to 2.1, so right as soon as, you might notice how these two are overlapping. Different if statements can overlap, and it's actually kind of beneficial because then you're running 2 of them at once. So since this is at 0% power, I'm also going to run this at 2.1 seconds, and it's going to go to 4. So basically, since these two are running at the same time, they're going to run at the same time. So this is telling it to stay at 0 motor power, and then it's going to do robot.drivetrain target adjust. And if you watch the Limelight video I made, it target adjust just makes the robot align up with the vision processing to then look at the tape and then line itself up, so then it can make a better shot right towards the center. Then from there, that's stage 3. Moving on to stage 4. If my time is greater than or equal to 4 seconds, which is what we ended with last time, and my time is less than 7 seconds, it's going to move the robot rotator up. So if you remember correctly from my rotator video, where I talked about using sparks, that is where you move the thing that makes our robot shoot the ball. So it's basically our aiming mechanism. So if we look into that, so if we go to rotator auto, it's very simple. Public void rotator auto, rotator power times by 0.25. So it's literally just moving the thing by 0.25%. And then from there, that's stage 4. Moving on to stage 5. If my time is greater than 7 seconds, which is what we ended with the time, and my time is less than 9 seconds, it's going to run robot.fire ball fire auto. Which we look at that. That's just 100% power to our firing thing. So if you remember from my fire video, where I talked about our shooting mechanism. The way it works is two motors hooked up, one hooked up to a vector, the other one hooked up to a talon. It basically is just telling it, hey, turn those on to 100%. And then from there, this is also overlapping, so 7 seconds. So both these will start at 7 seconds, and one will end at 9.0, the one will end at 9.5. So this one is going to start revving up those wheels so then to shoot the balls. And finally, the barrel is going to turn on, causing the balls to go up, to then hit the shooter, to then fly out. And that should end up shooting them into the goal. From there, we have the ending statement. If my time is greater than or equal to 10 seconds, my auto finish is equal to true. And if you remember correctly, the auto finish, which is up here, this tells it to shut off. So it's a Boolean that just tells it to shut off. So this is basically telling it, hey, shut off the Auton when you're done. Which then it does, and we don't have to worry about it. And then finally, the last thing you need in this command is return my auto finish, which once again, if you remember correctly, it tells the Auton to just shut itself down when it's over. So that's how you do Auton with a command, or at least the command portion of it. There's still a bit more we gotta do. But basically, you can just do a whole bunch of if statements, and then using time, you can easily code this thing. And I've already tested this, and this has worked out for us, for our robot. So when we run Auton, it just does this fine and has no issues. The last thing you have to do, though, before your Auton is going to work, is you have to make sure that in the robot.java, you put it in the correct spot and you tell it to run. So robot.java has a lot of different spots that you might think it needs to go, but the correct spot it needs to go is you're going to scroll down a little bit until you find this thing that's called public void autonomous init. And what the init is it tells the autonomous what to run. So you have a lot of different autonomous stuff in here, a lot of stuff I've slashed out. But what this tells it to do is it tells it to, if autonomous command is equal to null, or is not equal to null, autonomous.cancel. So basically, if there's no autonomous command in here, it's telling it don't run an autonomous. But if you look right below, I do have one in here. So auton write dot start. And by writing that one basic line, it's telling, and by writing that one basic line, it's telling during Auton to run this command. And as I told you earlier, I have 3. So you're like, well, what happens if you have 3? Well, the easy solution to that is that you put them all in here, and then you note out the ones you're not using. So, like, let's say one match I want to use auto in front.start. So all I'll do is I'll go into autonomous init, unslash it, and then boom, it's ready to go. I just have to send the code to the robot, and then that's the Auton that will run. Let's say if I don't want that one, and I want auto feed instead. Slash the one that I just did, unslash auto feed. Simple as that. And then in your driver station, you would open it up to run autonomous code after you send it to the robot. This would be testing it during non-competition days. But during competition, the radio and everything is all set up for you, so you don't have to worry about turning the thing to autonomous. It'll just do it automatically. But then you have these little switches right here. So in the drivetrain, if you're running teleop, obviously you're going to run teleop. But if you want to try out your autonomous code, all you have to do is flip this switch to autonomous, hit enable, and then it's going to run whatever you put into this spot right here. So I hope you found this video very helpful on autonomous coding using time and that kind of stuff. You can also use other things such as encoders and other sensors and that kind of stuff to help you. But we used time, and then we also used a little bit of limelight stuff. I hope that you found this video very helpful and useful, and I wish everyone good luck this year, and I hope the force will be with you.